we have this one. And I just forgot to tell you something about the charges. I just want to tell it to you right now. We have the thing that I missed out was, what is E? E. This E stands for elementary charge. Elementary charge. Elementary is the basic. Elementary means the basic, and that is the elementary charge means is the basic charge, means the smallest charge you can call it, and it is also known as the charge on the proton. On the proton, just keep that in mind. It is not the charge on electron. E is not electron, it is elementary charge. E minus is electron, means electron, but E, simply E, is not electron. And if there is simply E written down there, this means charge on proton. Charge on proton. Charge on proton. But if it is given there minus E, so that is simply charge on electron, that is E minus, charge on electron. And we have some values also. 1 coulomb is equal to some 6.24 into 10 to the power 18 E. 10 to the power 18 E. It is charge on a proton. It is 6.24 into 10 to the power 18 E. That is 1 coulomb. And 1 E has 1.6 into 10 to the power minus 19 coulomb. This is 1 E, that is the charge on proton is this much. This is the charge on proton, and if you just add one negative sign right in front of this, it becomes a charge on the electron. So let's head to the next slide. Here we have this. So I just did the electrostatic force in the previous, whatever you say it is. I just did it. So I'm just going to tell you what is electric field. Electric field for no, sorry, not electric field. It is something like anything in yes, electric field. What is electric field? The charge electric field, that is simply written as E, is the charge it is force per charge. Force per charge, that is electric field. We can have an example to explain it. To understand it, I need to explain you and you need to understand. So this charge, right, we have a charge, this charge, let's say it Q, this is capital Q, and another charge we have put it here is a test charge. There's another charge, it is a test charge, and this is the source charge. You can call it a source charge, that the charge you have at the source. This charge creates the electric field. This charge creates the electric field. Which one? This charge creates the electric field. this one creates the electric field. And the test charge kept here, it is small q, and distance is d between both of this. So as we just learned here, the electric field is force per charge, per unit charge you can call it, but the force per charge would be the correct definition of it. So you can just you just know the formula, that is K Q1 Q2 by R square. And if you just substitute this, I just said that force per charge, so you have the source charge, that is K, and this is Q, the source charge Q by R square by is equal to F by small q, and that is the electric field. This thing is electric field. You can just write it here, E, the capital E is this. Electric field is equal to F by Q, that is K Q by R square, KQ by R square. That is your formula of electric field. And what about the unit? You can just check it out from here. It is Newton, and this is Coulomb. Newton per Coulomb. You can just write it here, per Coulomb. So this is the unit of electric field. So let's head on to the next page. Okay, so now we have another explanation here. I'm just drawing it up. We have a charge kept here, a charge kept here, and another small charge kept right here. This both things are apart, 2 meter apart. 2 meter apart. These things are 2 meter apart. 2 meter apart. And this is the capital Q, and this is equal to 1.6 just some 1. I'm just cutting it up here, 1 second. Black. Right. We have 1 into 10 to the power 6 minus 6 Coulomb. It's a pretty big charge, but we have to take it for the sake of calculation. So this is this much, Q is this much, and we have to calculate the electric field. We have to find the electric field. What is the electric field on Q? On Q. What is the electric field on Q? As we know, electric field is force per unit charge. Force per unit charge, and we just learned in the previous slide that force per unit charge is equal to K into Q by R square, and so if we solve this thing, we just get it something like, we have K, the value of K is 9 into 10 to the power 9 into 10 to the power 9 into Q, that is 1 into 10 to the power minus 6, 1 into 10 to the power minus 6, and the R square, that is 2 meters, so it becomes 4. And after solving this, we have 2250. This is the electric field on Q. After finding the electric field, and the what do you call, the unit is this. After finding the electric field, what we need to find is the force on Q. We have found the electric field. Now we have to find the force on Q, the small q. This I just forgot to write it here. This is the small q and this is the big Q, and so we have to find now the force. What is force? This thing is electric field. This whole thing, that is kq by r square, is electric field. And if we multiply the charge, this charge up here, we have the force. So we can calculate the force very easily, that we have, that is electric field into the charge. So that is equal to, we know electric field is force per charge. If you have to calculate force for this much q amount of charges, then you have to just multiply it by the force per charge, that is electric field, q into E. This is force. And just keep in mind, I'm doing just the magnitude thing, I'm not going up to vectors. So q into E and q into E. We have to find the force, and I just put it in here. Oh, I forgot to write up here the electric. Yes, this is 1 coulomb charge. I forgot to write it up here. So I just multiply them. 1 coulomb, 1 into 2250. So I just get 2250. That is about this. 2250 and 2250, and I just told you in the first slide, I think that the forces, if the forces are positive, if the force is positive, then there is repulsion. If there is a negative force, then that means attraction. So here we have a positive force. That means there is a repulsion, and that means the direction of this force is outwards. So this force is going out. So we just did this thing. So this much is over. Now the next slide is about